So let me say a few words about today and what we're trying to do. As Zach said, we started the history of this colloquium a year or so ago, but it's really about building a community. We became very intrigued with this subject of cognitive systems, which you may ask me to define. I am not going to define it. I think we're going to further refine it throughout the day. But we became very intrigued with this subject 3 or 4 years ago as we developed and introduced to the world the now infamous Watson system. We've been working in IBM Research ever since to advance the technology, and you'll see lots of that today as you tour the labs. But we've also been busy in terms of applying that technology to a number of different problems and industries, and I think you'll find that fascinating as well. So let me just spend a few minutes, because I stand between you and really great speakers, but I want to give you a little bit of introduction in terms of how we at IBM are thinking about this subject and what is it that we're doing. First of all, I guess the sun never does set on IBM, at least IBM Research. We now have 12 labs around the world, reaching out not only to the smartest people we can find around the world, but the biggest problems. And you're going to see that in some of our speakers and partners today, all the way from our neighbors here in New York City to friends in Europe and in Brazil that are dealing with some of the most interesting challenges in the oil and gas industry. So this global reach really gives us, again, access to the best and brightest people, but also the most challenging problems where we can apply cognitive systems. 2014 has been a very, very active year for IBM in this space of cognitive computing, cognitive systems. It does not seem possible that a year has gone by, Zach, since we were in this very auditorium talking about this subject, where we had sort of ideas and dreams of what we would do in the area of cognitive systems. So let's talk about what IBM has done over the last year. Well, first of all, in January, we decided that those 12 labs and 3,000 or so world-class researchers, that we would dedicate about 1/3 of that organization, someplace between 800 and 1,000 people, to this topic. We felt that strongly, that this was so important to IBM's future and our clients' future, that we were going to put our brains and our money where our mouth was. We followed that with an announcement that we were going to invest $3 billion over the next 5 years to develop the core technology for cognitive systems. Technologies that would drive not only performance, but extremely low-power devices, so that we could use more brain-inspired, if you will, technologies to power the future decades of cognitive systems. An investment that literally no one else in the world has even come close to matching. We then went on and said, okay, we need to not just have cognitive boxes or systems in locations. We need to bring cognitive computing and the types of challenges and solutions to the cloud. And we took a technology called Bluemix, introduced it on our global cloud soft layer, and now can bring technologies like Watson any place in the world, not just to, say, again, our friends in New York City, but Watson cognitive computing onto the continent of Africa to deal with some of the challenges that we've got real time on that continent in areas like healthcare. That was a big step, because that really allowed us to connect globally our 1,000 or so researchers on the same platform, and again, you're going to see a lot of their work when you get down into our labs midday. We expanded our partnerships, and I'll show you a map in a minute. Universities are so critical to this effort in so many ways. Obviously, we want to help educate students. Obviously, we want to tap the research. But this is really, in our minds, creating the long-term future of this technology. If we don't do this, this will be a short-lived effort in our mind. And then I'd say the capstone was we announced in February that we were going to form a new group, a new division of IBM around cognitive systems, around Watson. and put $1 billion behind this, and several thousand people. We opened up a new headquarters just a few weeks ago down at Astor Place in New York City, right in the middle of Silicon Alley. If you're down there, get into this building if they'll let you in. If they won't let you in, call me and I'll get them to let you in. It's an amazing, amazing place, amazing facility. This is where we're going to bring our clients and our partners to really not only showcase our work, but roll up our sleeves and do work with our partners. Now, just to sort of signify the importance of that, the last time IBM formed an independent vertical unit was the IBM PC. So we believe that this technology, these systems, are going to be as or more transformational than the PC that we introduced back in 1980. And I think, Ginny probably wouldn't like me saying this, but $1 billion is like jacks or better to ante up and get into this game. Before this is all said and done, we're going to spend a lot of money to make this a reality and put our best and brightest brains behind it. So 2014, you know, I think, Zach, if you asked me would we have accomplished all of that in 12 months, I'm not sure I would have said that a year ago. I can't wait to put this chart up next year and say what we did in 2015. Our ecosystem is really taking shape. A year ago, this is the map of partners. There's a few dots of pink dots of developers, and there's a few university partners. Fast forward to today, a number of universities around the world, and if you introduce our development partners, again, several hundred, the map really starts to fill in. So this thing is not only growing here in the States, but is growing globally, all the way from Australia through Asia, and obviously now into our lab in Kenya. So again, tremendous growth in just 12 months because so many people, universities, development partners, are seeing the benefits of cognitive computing. Now, why the sort of the sense of urgency? Well, I constantly use this chart to remind myself and people I talk to that this is what's coming at us. This tsunami of data is coming at us, and we're already buried in it. We're already having difficulty extracting information from this not only large quantity, but very fast data, very uncertain data, full of noise, and very, very unstructured data. And those are tough combinations for computers, computer systems to deal with, and almost impossible for human beings to deal with that much information. And we'll hear that, I think, that theme throughout the day. So given that, I think the race is on. The race is on for we as humans to build systems that can deal with what's coming at us. If we don't, it's going to just swamp us. And I think it's going to result in a loss of opportunity to improve our lives and improve so many, many industries. And I think the first groups that can deal with this, the first people that can build the systems, the first companies that can build the systems are going to be hugely, hugely successful. So it's all about building things, objects, tools to deal with these kinds of problems. And we as humans have just classically done this, whether it was trying to communicate over long distances or build microscopes, telescopes to see farther, see better, or, of course, computation and building devices to help us do computation faster than our human brains can do. Fast forward, it's amazing what we as human beings have done to augment our capability to think, travel, see, etc. Today's smart devices, incredible, incredible communication devices, but also data transmission devices. Our crude optical microscopes now are literally moving and imaging atoms and molecules. And the computer systems that we've built for computation are unbelievable. 20 petaflop system that IBM delivered, largest in the States, to Lawrence Livermore Lab, and we're chasing now exascale computing. Incredible computational power. So we as humans are I think, fantastic at building things to augment our capability. Not to replace what we do, but to augment our capability. And so I think much of the day will be centered around a discussion of, okay, how do we augment our cognitive capabilities? How do we augment this 20-watt or so device that sits in our skull? I think to do that, we need to understand how the brain works, because we want to be inspired by some of the techniques and mechanisms that evolution has produced over the billions of years. But we also want to, as one of our speakers will really talk to us about, we also want to interact with these systems in completely different ways. And in order to do that, I believe, and I think many people believe, we really need to understand how this thing works so we can effectively interact with it and augment our cognitive abilities. So we're going to have, I think, some very interesting speakers that go way, way deeper than right brain, left brain. But, you know, in a sense, what we're trying to do, again, is address many of the more right brain activities in the cognitive systems versus purely computational areas. What we need to do for these systems beyond a simple Watson-like Q&A system is not trivial. It's not trivial. We need to move from English to multiple languages so that we can interact with humans around the globe. We need to go from simple one-line questions and one-line answers to full dialogue, because I think that will bring out a whole new dimension to the interaction. Our Watson system today, great at natural language, but I like to always say it's blind. It cannot understand images. And 2/3 to 3/4 of that tsunami that I showed you in data is going to be in images, in videos, in very complex things that are difficult for systems to understand, and on and on and on. So we have great challenges ahead of us. Any one of these problems is a massive research project in and of itself. But when we get there, not if, when we get there, we're going to have systems of incredible capability. So I like to think about the challenges ahead in sort of 3 buckets. And in a sense, this is the agenda for today. First, what are the kinds of applications and challenges for systems of this sort? And we're going to have today 2 fascinating speakers. One dealing with massive data in the oil and gas industry, and another speaker that's dealing with enormous amounts of genomic data, working really at the clinical level to try to translate this into impact in the world as we speak. So the whole area of applications is enormous. Secondly, this area of interacting. It's back to this, to really interact with humans in a much more synergistic way. We have to understand how this works, and we need to use all of the I/O devices and capabilities of the brain to really get man and machine versus machine. That, I think, is going to be the magic. And then lastly, the underlying technology itself. And I think here, I don't believe in our lifetimes we're going to reproduce the sort of underlying technology here, but I think there's so many things we can learn by more deeply understanding how the brain works. Because again, it's no accident that evolution sort of took us to where we are with this cognitive system. So our day is very much structured around these 3 topics, and I think you're going to find it's going to be a very, very stimulating and exciting day. And again, the day will be great if you just sit and listen. I think you're going to walk out of here with lots to think about. But if we really interact and engage, not only here in the auditorium, but out in the halls and down in the labs, it's going to be an incredible day. So thank you all for joining us today, either physically here in Yorktown, or for those of you that are watching and monitoring from other labs around the world. We're going to have a fantastic day. And if there's anything you need, grab somebody with an IBM badge and we'll take really good care of you. Okay, thanks very much. Zach, back to you.
Good job.